acceleration of gravity at the roof of this building and at the basement of the building are not the same. Now, we don't have any measuring device here which can measure the difference between it, but it is not the same. There are people who do measure those differences. On Mars, it's about 3.7 meters per second squared. This is a scalar quantity right here. Acceleration is, we're talking about vector acceleration, but little g itself is a scalar. So whether it is positive, when I write down my acceleration here, whether it's positive or negative, in this case, depends upon Kevin. My acceleration here is, therefore, negative 3.7 meters per second squared because of Kevin. We have one other piece of information that's not explicitly given in the problem, but it's understood from the problem.
Final velocity.
Which is
0.
Because I'm trying to figure out how high does the ball go. When it reaches its peak, it stops before it turns around. And so we know that. So now we can go to our cake formulas, because we will assume acceleration is constant. And I'm trying to find delta x. So which formula is probably the one we should use for delta x? That involves t.
Second one.
Well, the second one was the
Squared.
Yeah, that one. So I have v final squared equals v initial squared plus 2a dot delta s or x or whatever letter you happen to be using. Let me point out there's two ways of multiplying vectors. One way is called a dot product, because there's a dot put there, and the other way is a cross product. Cross products we'll get into in chapter 9, 10, somewhere in there. With a dot product, you're multiplying parallel components. With cross products, you multiply perpendicular components. If you think about a cross itself, the cross, it's written this way, not that way. The cross are two small perpendicular line segments. All right, so vf squared is equal to 0, is equal to 20 squared, plus 2 times negative 3.7 times delta x. In a one-dimensional problem, you can just write it like that. Make sure you keep the negative sign. I know displacement is going to be positive. My acceleration is negative. So when I multiply vectors, do a dot product between vectors in opposite directions, I'm going to end up with a negative. There's the negative there. Doing the fancy math, I get negative 400 is equal to negative 7.4 delta x. Whatever that is. So, how does 59.3? I don't know. Someone be kind enough?
54.05.
Thank you. Remember, this is physics, not math. We are not the barbarians of math who would just leave units off. You gotta put them in. Technically, it's displacement. So it's going to go 54.5 meters up. So now the question is, how long, at what time, is the ball 100 meters above the throwing point? So before we do any math at all, what's the answer?
Never.
Why?
Because it peaks at 54.05 meters.
All right. So let's say that you didn't know that already.
Okay.
Where would it show up in the math? Well, let's write down the big five again. So I got delta x, vi, vf, a, and t. See, I'm trying to find time. Acceleration, negative 3.7 meters per second squared. Final velocity is, I don't know, initial velocity is 20 meters per second. My displacement is 100 meters above the throwing point, and Kevin said that would be positive 100. So which equation would we use? And the one without the F. Pardon?
Third one.
Which was,
Displacement equals, initial velocity.
the VIT
Yeah.
plus. All right, so I've got 100 is equal to 20t minus half of 3.7, 1.85 t squared. I have a quadratic here. I would recommend quadratic formula, but I tutored a student years ago who would always complete the square. In essence, he was deriving the quadratic formula every single time. But ultimately, on how your mind's working at the moment that you need to use it. I personally like the first coefficient to be positive, so I'm gonna bring everything over to the left side. 1.85 t squared minus 20t plus 100 equals 0. And then plug and chug. So time is equal to 20 plus or minus the square root of negative 20 squared minus 4 times 1.85 times 100 divided by 2 times 1.85. Now, for those of you who don't happen to remember the quadratic formula and really don't want the tune running through your head like it is right now, God, wish I'd never seen that video. It's usually at the top of the first page of a test or quiz. If I don't give it to you, then you can ask. If you want to mess with other students in the class, and you know you don't need it, you can always ask for it and have you put it on the board, and perhaps make some students go, wait a second, I didn't use that. Where am I supposed to use that? So anyway, so we get to here. And what's going to happen here is you're going to plug it into your calculator and you'll get an error. Why will you get an error?
There's an imaginary number.
Imaginary number, yeah.
So this part right here will be negative. This is known as the discriminant. I hope I spelled that right. It's the discriminant. Discriminant. That might be an int at the end. This will be negative, which tells you one of two things. A negative under the radical tells you either the problem is impossible, which it is in this case, or you've made a mistake. What you should never do is get a negative under the radical and go, oh, I can't deal with that. I'm just going to get rid of the negative sign to make it easier and then continue working. The negative sign is telling you you made a mistake or the problem's impossible. So one thing you could do is go sort of picture what's going on in your head here, and throw a ball up at a certain speed. Is it possible that it doesn't reach a certain height? Yes, it is possible. Especially if you've done the first part, you know it can only go up to 54.05 meters. All right, so in the last moments, let's see. What is this? This is 19, so today is Tuesday. Master set 02 is due a week from today. And, there, I don't know what I put on Blackboard, but that's the official, we did. And next time, I will assume you've watched the videos and hopefully it'll make more of an impact. So next time we'll talk about two-dimensional motion, which is chapter 3. And then when we're done in chapter 3, we get to talk about when the test is, which I believe Kelly was asking about earlier, and she really wants to know. I could just surprise it on you, that we could do it that way. All right. I'm willing because Kelly says no.